Thank you for joining me as we explore how we can connect functional safety and quality risk management. This presentation is hosted by Desmond Mahadio of Plateau, North America. The presentation was originally planned to be delivered at the WCX SAE 2020 conference in April of this year. However, due to the current situation, it's now being done in a digital format. And now a little about me. My name is Desmond Mahadio, and I'm currently the Program Manager for Plateau, North America. I have more than 2 decades of experience in the automotive manufacturing industry, as well as other industries such as service, distribution, logistics, and warehousing. I'm a qualified mechanical engineer, a Lean Six Sigma Black Belt, a certified quality engineer with ASQ, and a QMS auditor for IATF 16949 and ISO 9001. As you can see, over the years, as a management professional with a passion for quality, I've contributed to the industry across a wide spectrum, which includes consultant and risk management. My volunteer work includes standards development at the international level, working with over 45 member countries, and the American Society for Quality, where I'm currently the chair for the Toronto section for 2021 and past Deputy Regional Director for Canada. I have presented and hosted workshops in Canada and in the USA. Some aspects of this presentation was done at the GYRS Reliability Conference that was held last year in August of 2019 in Detroit for the Automotive Division of the ASQ. We are going to discuss this morning the increased demands on automotive engineering, as functional safety and overall quality risk management requirements are being challenged due to the acceleration of the innovations, and we'll look at the functional safety processes and technology that are being enabled to meet this challenge. We will look at the current state with the impact of Industry 4.0 on design and manufacturing, what is needed to address this, and how we can enable Quality 4 to connect functional safety and quality risk management. To deliver this, we need a combination of people, processes, and technologies to address these changes. For the safety life cycle, we need to look at what can be done to better improve the effectiveness and collaboration required to support design from the concept phase all the way to decommissioning. For processes, we are seeing new regulations and guidelines that industry must now follow, as well as specific CSRs or OEM specific requirements. These impose different processes that integrate functional safety into a wider view of quality risk management. We will review the key points of ISO 26262, the regulation that governs the automotive sector for functional safety, and the AIAG&VDA FMEA-MSr guideline that was published in June of 2019 in order to set the stage of what is required in our design approach. We'll look at technologies. Today's technologies are falling short for supporting new processes for risk analysis. In the recommended design guidelines and regulations such as ISO 26262 and AIAG&VDA FMEA-MSr. The technologies for capturing lessons learned, collaboration in real time, the document-driven systems and processes that have been employed in the past. A lot of them are based on paper and Excel, and with the degree of transparency and accountability that is required, they will fail to meet the challenges. We need to rethink our methods to deliver quality and safe vehicles and limit warranty costs, since a company's health is primarily in minimizing the cost and damage to recalls. There has been a lot of talk about Industry 4, the new reality. What is the impact? This diagram is taken from the World Economic Forum, and it shows the evolution of industry in stages from Industry 1.0, 2.0, 3.0, and 4.0, from the 1780s all the way to our current time. It is the new reality. It started with the advent of the steam engine. We saw mechanization in factories in the first industrial revolution to mass production, spearheaded by the automotive sector, and then the introduction of early computers and robotics by the 70s, to today, where we see cyber-physical systems, Internet of Things, rise of artificial intelligence, and automated driver-assisted systems, or ADAS, in automobiles and mobile technologies. The world has changed rapidly, and we see early acceptance and adoption of these technologies as they are implemented in consumer products, and consumers become reliant on these systems. Indeed, the speed and impact of this fourth era has no historical precedent. Innovation, new ideas pushing companies to be at the forefront in order to gain a competitive edge, is driving this accelerated evolution. What took months to develop years ago now takes a few days or even less. What is the impact on quality, safety, and how do we manage the risk with the degree of complexity that we see now? This slide is taken from a report published by Recallmasters from the web, and it shows data for 2018. You can see right up in the top left-hand corner that software electronics account for more than 17.8 million vehicles for 2018. And according to the report, more than 30% were from the NHTSA, which is the National Highway Safety Association. And these were mandated of the total of the 47 million vehicles that were recalled. Complexity is driving harder challenges in design. Design engineers are facing these challenges, as well as the ability to manufacture across multiple industries. What can we do to help mitigate this? And it is not only in the automotive industry. We see it for all industry sectors, from pharmaceutical to food, and these are all resulting in more stringent regulations in order to protect the end user and safety from harm or fatality. Looking at warranty and recall costs, these are scary numbers. The cost of recalls from claims and accruals have increased 4 times over the last decade, and the impact is compounding year over year. The costs are staggering, and they continue to rise. This slide is showing the data from 2016. In 2016, we had 11.8 billion in claims, 10.3 billion in warranty accruals, and $22.1 billion. This was all a 26% increase over 2015. This cost is passed on to consumers, and we saw a steady rise and a steady increase in prices. There is also the impact in the used car sector for cars that have outstanding recalls, as these may not get fixed if there were safety issues, and they could pose danger and compromise the safety of the consumer. The industry has realized that now is the time for change. There has to be a consolidated effort to reduce this, especially since it can impact the safety of the consumer. The response that the industry has made has been to introduce new regulations such as ISO 26262 and the new AIAG&VDA guidelines, SAE J1739, and these have all been in the effort to control this and put emphasis on safety and risk mitigation. The automotive OEMs are also directing CSRs, which are always changing and evolving. Of course, there are many elements that are involved in its design for safety, quality, reliability of vehicles. And some of these include physical testing, digital simulation, and other areas. So the guidelines, the regulations, the CSRs, as a response, are only part of the big picture. Let's now have a look at ISO 26262, which specifies functional safety. This is an adaptation or a variant of the IEC 61508, and it is used to comply with the specific needs of electrical and electronic systems that are embedded within road vehicles. It relates to the functional safety of these systems. What is it all about, and how will using this provide the functional safety required? I'm just going to spend a few minutes giving the overview of the standard. The standard is made up of 10 parts or sections. The schematic shows the standard, and it has the typical ISO structure. If you look at the center, you will see the input from the left side, from section 3, to processes, to the required output on the right-hand side. Below that, you'll see the supporting processes with the ASIL-oriented and safety-oriented required analysis. The ASIL is a key component for ISO 26262 compliance. The ASIL is determined at the beginning of the development process. The intended functions of the system are analyzed with respect to possible hazards. The standard specifies a functional safety life cycle for automotive products. So in a nutshell, this standard deals with the safety life cycle for electronic and electrical systems in road vehicles. Here is another view showing the product life cycle. The dark V is from the concept phase to production, operation, and decommissioning. The light gray W shows the interaction and design at the hardware and software level. The overlapping V and W shows their interrelation through the product life cycle. I know this diagram may look confusing, but it reminds me of when I'm working on standards development and we try to capture systems approach of the standard in a visual. Trust me, it's not easy. And after several iterations, it ends up looking like this. You can look at the 9001, 13485, and the recently published Innovation Management Standard, which I've just contributed to, and also the new Strategic Management Standard. We have to put a schema which captures the system. But I'm digressing here a bit. We see 26262 encompassing all systems and cascaded throughout the supply chain. There's the Advanced Driver Assistance Systems, ADAS, the by-wire systems, the ESC or Electronic Stability Control, and we have also passive and active systems. The focus of ISO 26262 is on possible hazards caused by malfunctioning behavior of safety-related systems. I have put together this simplified diagram to better capture the essential aspects of the standard and how the ASILs are integrated. So let's look at the first thing, scope. Electronic, programmable, safety-related systems. That is the scope, and it has to be in the automotive sector or automotive systems. What is the purpose? The purpose of the standard is to ensure that systems are designed with the appropriate level of rigor for their intended operation. Now, what is meant by appropriate level of rigor? What is rigor? Rigor has two components. It must provide adequate safety, which means it should not cause harm or injury to the consumer, and at the same time it has to have a high degree of intrinsic quality. Of course, quality in this context means customer satisfaction, so you must meet the expectations for both the stated and implied needs of the customer. The thing is, a product that has a high degree of intrinsic quality is more likely to perform safely. So the focus is on risk mitigation by analyzing risk and integrating it with the quality of design. This risk-based approach manages the residual risk, and it is broken into three specific areas: severity, exposure, and controllability. Severity. What is the potential harm if a failure occurs? Exposure. What is the probability that this will happen? What is the probability of occurrence? Controllability. What is the ability of the system to avoid the harm? These are then broken into the ASILs, which are automotive safety integrity levels, and they're ranked from A to D. And this is how you do your first stage of looking at functional safety. In the functional safety life cycle, the benefits of evaluating risk and doing hazard analysis is early in the development process. It is important for companies to understand that the goal is to analyze the risk early in the development process. They need to establish the safety requirements and fulfill these requirements by testing during development, both the digital and physical testing. Collaboration with people, process, and technology is required throughout the life cycle. The challenge, of course, is in implementing the standard and ensuring it is used and applied to current processes. Remember that typical of management standards, the ISO 26262 specifies what must be done. However, it does not provide techniques to achieving it. That is, how. The how to analyze process and assess risk and to mitigate them. This has to be done by using techniques such as HARA or Hazard Analysis and Risk, FMEA, FMEA, your failure mode, effect and diagnostic analysis, failure mode, effect and critical analysis, criticality analysis, and of course the new guideline, which is the FMEA-MSr. One of my favorite topics is cost of quality, and this is something that as quality professionals is how we view quality management as being an important aspect of impacting the bottom line. From looking at areas that contribute to failures and implementing solutions to reduce or eliminate the costs associated with each of its categories. Once analyzed, it focuses investment in these areas that could provide maximum benefits. Monitoring these costs through a cost of quality program drives improvement and yield considerable results. I have successfully used this approach with relevant KPIs to monitor and deliver significant results for companies that I've worked and consulted with. The total cost of quality is made up of two arms: your cost of poor quality and your cost of good quality. Cost of poor quality comprises of internal failure costs, scrap, rework, internal sorting, low OEE, and external failure costs, which are the complaints, rejections, warranty costs, and cost of sorting and recovery. So we see you've got your internal failure costs and your external failure costs. This is what is termed reactive, and when it occurs, there is no choice. You may be put on containment by the OEMs if you're supplying them, and the impact is felt on your internal costs as well, because you may have to do containment, and because of the containment, you'll do 100% sorting at your location, which means your cost goes up. Cost of good quality. Now there are two categories in the cost of good quality. There's the appraisal cost, which is all inspection and QMS auditing to ensure all is well, that your detection system is working. And the next one is prevention. Prevention talks about training, investment in technology, and implementation of methodologies on a collaborative platform that can do risk mitigation effectively. The benefits of this is enormous, as good risk management incorporated with functional safety reduces both your internal and external failure. FMEAs is one such technique. But what do we see? Or rather, what have I seen from my years in quality? The reluctance to invest in prevention or technology that enables good risk quality and safety mitigation of failures is oftentimes missing. The recent guideline for the merged AIAG&VDA was published last year, June, and it included FMEA-MSr, and what it means is failure mode effect analysis, monitoring, system response. This is incorporating a system to monitor, such as ADAS, and to provide a response to maintain the system to target by reacting and adjusting. The adjustment could be auto or in an active closed loop manner, or it could be passive, which means it requires the driver to react due to an audible or visual system. And I've got the slide, and you can see as the car drifts out of the lane, there is a lane keep assist, and what it does, it monitors and it maintains it to the target, it reacts and brings the car back to the center. The new published guideline for the AIAG&VDA, they have adopted a systems approach to FMEA and FMEA-MSr, and it inherited most of this methodology from the VDA standard that was used in Europe. The approach analyzes structure, function, failure for FMEAs. In the structure, you have the focus element or the item or aspect that is being considered, and this could be a system or a subsystem. The modes of failure are detailed. In the system structure, as you can see from the diagram, the effect of the failure will be on the next level up, as well as all the way to the vehicle level if it is a safety item. The cause of the failure comes from the lower level down in the structure. This chain forms the basis of the analysis. For example, if you are a manufacturer of the caliper of the brake and you're considering a failure mode that say the caliper does not close or compresses the pad, the effect will be on the disc. But since this is a safety item, if the disc does not slow or stop, then it could result in fatality to the next higher level up, because the vehicle wouldn't stop because the caliper did not clamp the disc, sorry. The cause would be from the subsystem that activates the caliper. And this is how the chain works. It considers how systems can fail while being used by the customer to maintain safety or compliance. It also utilizes the same 7-step approach that the DFMEA is using, so that this can also be done together with the DFMEA. FMEA-MSr is applied when diagnostic detection is necessary. Significant focus of the analysis is to determine if the system or the end user will detect a failure if one such failure occurs. The designer, as you can see in the loop, rather than redesign to mitigate failure causes, the question is asked, can the failure be detected while in operation? If it can, then a monitoring device is employed that can provide detection. This detection of out of control feeds back into the system, and it then mitigates the failure. And of course, this could be an active or passive system. So the functional safety becomes the basis for the FMEA-MSr. And in your functional safety, we dealt with the ISO 26262, with the WAT, and you could use methodologies such as the HARA, FMEA, FMECA that we spoke about earlier. We have reviewed the processes as well as regulations. What is required for safety and what tools do we need to use to perform the analysis, such as FMEA-MSr? We need to look at the big picture to understand this at the organization system level. There are three aspects: People, processes, and technology. And you may have heard me mention them several times during this presentation. The key here is that there has to be an integration of all three of these with quality risk management that includes functional safety. Let us look at people and the technology to enable what people within the organization need to do. We talk about teamwork and collaboration, supplier, customer, design and manufacturing, the systems for knowledge management, the ability to be able to capture and to share lessons learned and to have the failures consistently recycled back into the engineering, and also for your design failure mode effect analysis and your DFMEA-MSr. We need to have avoidance of these repeat issues and recalls. We need to be able to have technology that can have effective data acquisition for analysis to enable speedy decision making. We need to be able to acquire effective tools for managing risk and effective software versus spreadsheets and outdated software. This is how technology will enable people. This wheel chart is taken from research done by the LNS, and it talks about quality 4, quality initiatives in response to Industry 4. We spoke earlier about Industry 4. So from Industry 4, we have Quality 4. What is Quality 4? Quality 4 is digitalization of quality using technology as the enabler. Again, the key here is using technology as an enabler to drive management of systems and compliance to deliver results. It captures, in this diagram, the people, process, and technology very good, and it divides it into segments for easy understanding. On the outer wheel, you see process, technology, and people, and then there are segments within that for data analytics, management system, connectivity, scalability, competency, leadership culture, and compliance, with one section for collaboration. So this is Quality 4, and we need to enable Quality 4 within our organization. The next few slides are taken from a recent study by the BCG in partnership with the ASQ and the Deutsche Gesellschaft für Qualität, which is the DGQ. They sought to better understand technology's role. This is study, or this study that was done by the BCG is readily available on the internet, and I encourage you to read it as it highlights some key points about what they discovered about utilizing technology in their survey. The study found that Quality 4 is much more than technology. It is a new way of managing quality in which digital tools enhance the organization's ability to consistently give customers high-performing products. As their study demonstrated, Quality 4 in no way diminishes the role of people in assuring quality. Indeed, giving people the skills to apply digital tools and to tell data-driven stories will become an essential part of ensuring quality in the factory of the future. Across manufacturing industries, the companies that will win in the 2020s and beyond will be those that use digital to redefine themselves. To implement Quality 4, companies need a structured approach that includes prioritizing use cases to resolve critical pain points, defining a clear vision and roadmap, establishing technology and data enablers, and closing skill gaps. Companies must also manage changes across their entire enterprise system and be able to foster a culture in which all employees take ownership of quality. And those statements were taken directly out of the report of the BCG-SQ-DGQ survey. What it is saying is that we need to utilize technology to integrate functional safety and data quality risk management. What is the current state of affairs? 16% of all companies have started to implement. 20% have started to plan for implementation, and 63% have not even reached planning stage yet. So this shows that we are still lagging in adopting Quality 4 And for us to really get ahead of the curve, we need to start implementing and move from planning for implementation. Here is a layout showing the many applications at each stage of the value chain. Quality 4 throughout the organization processes, from supplier to customer, all the way from R&D, procurement, manufacturing, logistics and sales, service and after sales, and cross-functional. For this, let's focus on centralization of quality data, quality management system, transparency and cross-functional. Technology, we need to use tools, we need to use data that is on a platform that enhances collaboration of people so that you can have real-time information. Your data acquisition is on par with the way your system and complexity is required to deliver. We cannot use outdated technology. We cannot continue to use the spreadsheets. This is where we need to enable quality 4 to solve some of the issues that we are seeing today. We need to act. We can no longer stand by and wait in this climate of accelerated change. Quality 4 has many applications throughout the value chain. The greatest impact is on research and development, design, and manufacturing. Those areas we need to integrate safety and quality risk management. We need to have real-time data with users on a collaborative platform to focus on preventive measures, technology to enable FMEAs and FMEA-MSr that incorporate functional safety and monitoring system response to provide efficiency and effectiveness to prevent recalls, warranty costs, and improve our COPQ, or our cost of poor quality, and drive continual improvement. Data analytics has become paramount. The timeliness, integrity, and relevance of data is critical to the survival of the industry. From the survey, across manufacturing industries, the companies that win in 2020s will be those that use digital to redefine the meaning of quality excellence. Thank you very much for listening. You can get more information by going to www.plato-1ns.com. Thank you once again.